Hi, my name is Hannah Bell, and this is my restoration ecology midterm. So restoration ecology is a process that seeks to help or aid the recovery of an ecosystem or natural area that has been damaged or repaired in some way. Could be human or could be natural. And so here's an example of restoration of a wetland. And so on the left you have before, and on the right you have after the completed restored wetland. So restoration ecology has some pros to it. It does allow you to repair an ecosystem that exists or formerly existed. It allows you to replant or reintroduce native species, as well as help native wildlife to come back to the area to maybe reproduce. And you're helping something that is beyond natural repair. In thousands, hundreds of years, it would not be able to repair itself on its own. But there are some cons to it. So some people still think that it is completely non-natural because you are aiding it and it's not the original ecosystem. You'll never have that perfect ecosystem again. It can be very costly, and typically a lot of people run out of funding when they're doing restoration, which can impact what the final product is. And the field has existed from about the 1980s to the present. It's become a lot more defined, a lot more common though, as restoration is needed in an identified field now. Here's once again an image showing a before on the left-hand side and after of a stream restoration. You can see they added a bunch of different types of native vegetation to help for a better ecosystem. There are three types of restoration. The first one is complete restoration, which includes all of the attributes of historic natural communities for that community. And a case study that shows this is the Walnut Creek NWR in Iowa. And they took what was once prior to European settlement, it was a savanna prairie grassland. And when Europeans came, they turned it into agricultural fields. And there are these remnant patches of that grassland. And so they took and restored it to that original pre-European ecosystem. And here's just one image of the restoration. Another type of restoration is ecological services, which is process-based, structural, or functional restoration. It could also be doing something with like chemicals, whether it's releasing chemicals that are trapped in an ecosystem. So based off that, I did the case study of the Bavarian Alps, and they redid the wetland there because it has peat soil and it was holding in the carbon dioxide, which could not escape into the atmosphere. So they went in, helped drain help drain the peat, which allowed for the carbon to be released. Here's an image of a wetland located in the Bavarian Alps that they worked on. And the last type is experiential, which is doing the restoration for humans that live near the area or in it. And this is usually for like parks, or it could be for aesthetic pleasing, like recreation, different things like that. A case study of this is the restoration of the Alfred Caldwell lily ponds in Chicago, Illinois. And so they restored the lily ponds, which had fallen into disrepair just due to overuse and lack of maintaining. And so they restored it so that birders and anyone could go and enjoy the lily ponds. Here is an image of the restored lily ponds to its historical time. Novel community is groups of species that have no natural counterpart, and we typically see them pop up in abandoned urban areas, whether this is buildings, like this image here, you can see that these plant community has grown there. It could be in parking lots. It could be really in anything that has been abandoned and plant species have started to grow there. A restoration plan should include a few elements, and they are the project purpose and goal. You need to gather background information to help you figure out that goal, as well as that background information will help you get a vision of where you want to go and then a plan together for that vision. So you need all those elements. Here is an image taken from the different processes or what they're going through in the Everglades. It's an ongoing restoration, but shows you the different stages from the restoration plan of the drainage flow and just maps and images of it. Restoration success is determined through the 9 attributes. And so by having different levels of success with those attributes, you can really get a well-rounded restoration and figure out if it was successful or not. Here are images of stream restoration before on the left-hand side and after of the Emscher River in Germany. And once again, you can see lots of vegetation was added to make it more natural. Some of the meanders were taken out, different things like that. The 9 attributes include similar diversity and community structure in comparison with the reference site you chose, presence of indigenous species, so your native species, presence of functional groups necessary for long-term stability, so making sure you're having those different relationships in the ecosystem, the capacity of the physical environment to sustain reproducing populations, so whatever you plant there or whatever species come, they need to be able to reproduce, normal functioning of the ecosystem, integration with the landscape, elimination of potential threats, whether they're human use or natural disturbance, resilience of natural disturbances, so they should have some degree, and self-sustainability. They need to be able to function on their own as an ecosystem. Some challenges faced in restoration are changing systems. We have an imperfect understanding of natural systems, so we can't really restore completely. We have a lack of record keeping over decades and time periods and centuries. There are lots of legislative loopholes you have to go through. There's specific unique site histories for every restoration. There could be conflict among users of what they want the end process to be or how they want a section to be used. And a lot of times there's a lack of funding and or time or both to complete the project. Opportunities to ecosystems and how they relate to human communities. We can enlarge preserves in natural areas. We can link habitats together through patches or corridors. We can restore remnants of communities that once were there and bring them back. We can do the restoring processes. We can have education and knowledge gain as humans and educate others. We can have an increasing of community capacity. So landscape scale restoration project. An example is the Nashua grassland in northern Illinois. It is a grassland habitat. The restoration was done by the Nature Conservancy and volunteers, and the goals were to restore the former agriculture fields back to their pre-European grasslands. The problem was the fields had been used for agriculture and kind of degraded over centuries of farming and ranching, and there were remnant patches of the grasslands. They used a technique of replanting native species that they could identify. They removed brush and invasive species. They monitored the growth, and they did do prescribed burns to help the grassland grow. Here's 2 images of the restored grasslands and prairies. A small-scale restoration was the Malapai borderlands in southwest New Mexico, southeast Arizona, and Mexico borders. It is a grassland and savanna habitat. The Malapai Borders Group and U.S. Forest took place during the restoration. They wanted to enhance the biodiversity of what lived on that grassland, as well as allow ranching to continue, since that is what those borders are used for sometimes. And they wanted to reduce a lot of the shrub coverage that had come up and revive the grasslands for wildlife. So there was a lack of fire suppression, which allowed for these shrubs to grow and not really let the grasslands grow because they need fire. And so they decided to reinstate a prescribed fire burning program, as well as for ranching, instating grass banking so that they could use different fields and not all the cattle were on the same field. Here's an image of them doing a prescribed burn at the Malapai borders, and just a kind of a blurry image, but of the plains or the grasslands themselves. A restoration with an experiment is the erosion control, which was done in Lakeshore Nature Preserve at UW-Madison in Wisconsin. It is a mesic forest, a temperate forest and prairies, lots of diverse habitats. Rebecca Kale headed the restoration from the university. They wanted to maintain herbaceous ground layer through the woods, and there was heavy foot traffic on the trails, as well as a lot of stormwater runoff, which led to erosion. And so they redirected foot traffic and stormwater runoff, but Rebecca was lucky enough to have funding put in that she could test out different types of erosion control methods. And she wanted to do that so that they could find out what would be best, but also to publish it for other people to do. And so she was for other people to access. So she was successful in that. Here's an image of one of the trails at the preserve, as well as a kind of meadow going into a field. A restoration with volunteer use is the Presidio in San Francisco, California. It is a very diverse habitat of forests, tidal marsh, and beaches. And volunteers did this restoration through the Golden Gate National Park Stewardship Program and the Golden Gate National Parks Conservancy. They wanted to protect endangered species and resources and provide public enjoyment at the same time. They had to fix the tidal basin because it had a lot of repairs needed and issues. And so they decided to conserve rare plants, as well as map the areas, remove invasives, do baseline inventories, and restore the tidal basin, of course. So here's images of Chrissy Marsh, which is where the tidal basin is that was restored, as well as a bridge added, and have some restoration with that. An ecological community is a group of species interacting and living together at the same time in the same place. And there are 4 ways an ecosystem can organize themselves: through community organization, community dynamics, community stability, and historical community. And ecological community dynamics are really how the communities vary throughout time. And succession drives this variation in communities, because they can be in succession for long times or not, depending on natural disturbances. So here's just the example of primary succession over about a couple hundred of years, and you can see how it goes from the pioneer species all the way to the climax community. Disturbance cycles help create the maximum biodiversity because they allow for several communities to be living together but being in different post-disturbance stages, which just allows for a variety of ecosystems and communities interacting with each other. And it really is a mosaic community that they produce. And so here is an image showing the stages of suppression following a natural disturbance. The example here is fire. The intermediate disturbance hypothesis tells us that species diversity is at its highest when there are intermediate frequencies or intensities of disturbances. So we need natural disturbances to help communities grow. And as I already said, natural disturbances do hold an ecosystem in a successional state for years sometimes, which kind of is how you get all those different ecosystems at one place. Here's an example of a natural disturbance, which is a forest, or I mean a fire, burning a forest, so it'll go into a successional state then. An example of keystone species that we didn't cover are prairie dogs. They live in colonies and burrows underground, and their burrows actually benefit up to 150 other species that call them home as well. So they're really important, as well as they're a very common source of prey out in the prairie, whether it's for black-footed ferrets, which depend on prairie dogs, and we've seen reintroduction of their populations, to birds of prey and really different types of predators. They also help fertilize soils with digging around and digging up plants and vegetation, but they are in decline. Over 95% of their population was lost, and they're very integral to prairies. So if we lose them, we'll see a lot of other species start to suffer. An ecosystem is composed of all the living and dead organisms in the area, which also includes your atmosphere, hydrosphere, and lithosphere. And then it also includes the interactions that they have with each other. And so here's just an example of a marine ecosystem and how it would interact with each other. Energy flows, it enters as sunlight and then it moves through the trophic levels. At this point, you'll have some energy lost in the form of heat, and then it'll leave in the format as heat in the last step. And here's just a little example of how that looks in an ecosystem with some mammals and then even some decomposers. A biochemical cycle is the transfer of chemicals between the ecosystem counterparts, which is your biota, your atmosphere, your lithosphere, and your hydrosphere. There's lots of different biochemical cycles. One of them is the nitrogen cycle. So we have nitrogen in the atmosphere. However, sometimes plants can't process the nitrogen. So we see nitrogen enter the ecosystem as a bacteria, and it is this loom root, or this bacteria that kind of latches onto the loom root nodules in plants, and decomposers help with this. And we can see then that the plants can intake the nitrogen through this, and then as a result, animals, wildlife intake the nitrogen, and eventually the nitrogen will make its way back up into the atmosphere to join the atmospheric nitrogen. Patches are small areas in a larger community that is distinct in its form and composition from the surrounding area. And so we typically find them within a development or developed area, and they could be like corridors or a park or something like that. But large patches are preferred because they have a larger interior habitat. And here's an example of a patch as a wildlife corridor, which goes over a highway linking some habitats together. Reference ecosystem is important because it allows you to gather baseline information when you're doing your restoration. It allows you to see what is possible and feasible and set goals of your own for your restoration. And you can also look at previous types of methods used or what methods you think could be used, or even potentially test out different methods for your restoration. And this image is the Talladega wetland in Hale County, Alabama. If I was in the area in the same region and I maybe want to do a wetland restoration, I could look at this as a reference ecosystem. Now, there are some reasons why you might not want to use a reference ecosystem. There could be limited records or data for the area that the only similar ecosystem to what you're doing a restoration. You have to remember that successional stages will keep an area for a very long time in one stage, so it may be hard to monitor the progress or to figure out how long you would need to have your restored area in a successional stage to be successful. And you have to be careful how you choose the data. Data could sometimes be biased, as well as there is no like ecological yardstick for you to measure everything by. So what might be measured or might incorrectly be measured in your reference ecosystem, you have to keep that in mind that your data could not be perfect. This is a restored wetland in Johnston, South Carolina. So this could be another example of an ecosystem if you were in the same area restoring a wetland. Project documentation is really important because it guides both your restoration but all future restorations on your site, but it could potentially help out other sites that are doing a similar restoration. Documentation allows you to share information with stakeholders and public during the process, as well as record and track volunteer hours if you're using volunteers. Some ways to document are notes, whether they're written, audio, GPS points, team reports, work journals, or photographs. Here's just an example of handwritten notes from the field. 3 ways to incorporate research into your restoration are through observing remnants. So an example of this was the Nashua grassland in northern Illinois. They studied the remnant patches of the pre-European settlement that still existed, and they based off of that and documents what to restore and what to replant. And then they logged all that information for future restorations or if it would need done again on that site. You could investigate historical communities. So example of this is longleaf pines in South Coastal Plains. They looked at all of the historical records and went through them to kind of figure out how longleaf pines grew and did so well in previous centuries and decades. And they saw that there was a lack of controlled burns and the longleaf pines need burned. So through that data, they were able to figure out the issue and re-implement the prescribed burns. Incorporating experiments in the field. An example of this was the Lakeshore Nature Preserve at UW-Madison in Wisconsin. They were able to have the time and money to build in experiments on erosion control and then plan them out and test them and then be able to publish that information so other people could access it. Early Naturalist by Catsby really made me think that while we need to document all of the scientific data, all the mathematics, all those different things, we also really need to or should think about including different things like what the soils could be used for, what the land could be used for, what has been used for, because he talks about what the soils, what they can grow, as well as having a lot of visuals and maybe even other senses. Just documenting everything that you see and can tell about that place will be really important to someone who isn't experiencing it at the same time that you are in whatever the year is. And just here's a visual. He drew this, Caspi drew this, the Carolina parrot, and included it in his documentation. Some categories of data include the physiographic information, which is your location of site, your soils, your landforms, and hydrology, your biological information, which is your vegetation and wildlife, your socioeconomic information, which is human population, demographics, zoning regulations, and historical land use. Climate, hydrology, topography, and soils play a huge part in your restoration because they influence the plant and animal communities that can live there and the ecosystem that can live there, as well as they influence and control the climate of the site and the weather and different things like that. And so what methods you use also are controlled by these because you need to use methods that are going to work with that climate, with that water system, with that soil, with that topography, those different elevations. And it can help you because you could potentially look at data of all this information over years and potentially predict the future landscape or how they might change, or also with climate change, really important that you could potentially predict climate, how that's going to change over years. Some helpful websites to use are NASA, NOAA, USGS and contract surveyor. Here's just the logo of USGS services. Biological and socioeconomic data are also important to your restoration because they tell you what species are present, what you should plant when you're looking at what plant communities to put in. They can tell you the historical land use of the area and what the current land use is of the area and how humans interact presently and in the past. And so here's just a human walking through a section of Everglades National Park in Florida, and you can see how they're using it. They're staying on the trail, they're hiking, whether it's for recreation or other uses. History and restoration ecology are very important because you need to know the historical uses of the area as well as what the historical communities were and the present communities. It helps to show you how the landscape has changed over time, as well as it gives you a starting point on the new projects because you're going to look at what the historical community was and you're going to figure out which one you want to restore. Sometimes you have options, and it will provide you with the community type or types that have been there over time. So here's an image of the Pinelands Road in 1928 in Everglades National Park in Florida, and they've documented this road and taken pictures of it throughout decades. So if you were going to restore this area, you could go through all the data and all the images that they had through various decades and look at how it's changed over time. Forest Service had some errors when they approached in our Pappy's Burn the Woods. And so some changes to make or think about if you're doing a similar or you want to incorporate in your restoration is to interact with the public, with the community, figure out what they know. They assumed that the people didn't know much about fire and weren't educated, which was wrong. So you need to interact with the community, figure out what they want, what they know, what the stakeholders want, as well as then potentially off of that, if it was fire suppression again, you could create classes off of that. You could create your educational handout from that or handouts from that. But you need to know what the starting point is and not just assume what they do or don't know. Some human impacts on natural areas. There's a lot of impacts that we have, but some of them are soil compaction, erosion, off-trail impacts when you go off, littering, and you need to create a plan to help mitigate these in your restoration during the planning stages. And so you could interact with the public for suggestions, especially how they want to use the area that you're restoring. You could create boardwalks so they're not on delicate ecosystems. You can designate specific trail use for like biking or ATVs or horseback riding. And here's an example of trail erosion at Assateague Island and kind of how they've tried to restore and repair it. So adaptive management is when there's work between practitioners and the scientists as they define a problem, create goals, and then develop modules to help predict the outcomes for the proposed actions. This creates a link between practitioners and scientists that is not there previously by creating a partnership. Volunteers are very important to projects, and there's just 5 approaches to engagement are offering trainings, especially at the beginning of their work or workshops, having good communication with them, ensuring access to any materials that they'll need during their project or their day or time there, provide a line manager who's another volunteer, but someone that they can go to and share frustrations with or whatever it is. And then at the end, try and share their story for others to see, whether it's like a success story or how they felt or something like that. 5 best practices are to define the rules and expectations at the beginning and throughout, create clear assignments or rules for those assignments, reduce volunteer risk by having them or notify them of the risk by having them fill out waivers, which takes legal action off of you, provide supervision while they're performing their duties, and receive feedback from them throughout the whole process, not just at the end. Local rednecks are ecosystem managers in a way, or help with ecosystem management because they do a lot of hunting and they hunt a lot of different species, which helps with wildlife and population control, especially on animals like white-tailed deer. And then not so much anymore, but they used to practice wood burning and burn woods. But an issue is that a lot of them have kind of encroached and moved to that area now, so they might not be able to, but they do help with fire suppression. Some federal legislation to keep in mind during your restoration is the River and Harbors Appropriation Acts of 1899, the Clean Water Act of 1972, and the Endangered Species Act of 1973. Here's an example of the Clean Water Act, the logo. Where to place a development, you need to consider the following things. If possible, avoid impacts to wetlands, streams, and other aquatic resources. If you can't avoid it, minimize or reduce the unavoidable impacts to the highest ability that you potentially can. You need to offset or mitigate for those impacts you're creating. And here's just an example of Detroit's plan to transform the city in the future. And they're going to try and instill new green areas as well as not damage any of the greenscapes that exist now. A mitigation bank is a site where resources are stored, enhanced, or preserved for the purpose of providing compensatory mitigation for authorized impacts. So here's just some of the mitigation banks that are located in the US. Clearly, there's banks in Florida and Georgia, but they're not listed on here. But this does also show that there's lots of states that don't have any mitigation banks. 4 options for mitigating impacts are to restore a previously existing or existing wetland or other aquatic site. You can enhance an existing aquatic site's functions. You can establish a new aquatic site, or you can preserve an existing aquatic site. Here's an example of a restoration that was done to a wetland in Sequoia and Kings Canyon National Park. So they decided to restore it. So determination of how a mitigation bank is done, there's 6 different ways or factors. Loss type, which has 3 impacts. Type A is impacting streams and it needs the most mitigation credits. Type B impacts isolated or disconnected areas, which could be seeks, bogs, savannas, different things like that. Type C impacts man-made lakes, shallow cove areas, impoundments, different things like that. And that has less mitigation credits needed. Priority category has primary, which is state and federal lands and other areas with special designations or are rare, so a wildlife scenic river could fall into that. And then a secondary category, which is vulnerable or uncommon aquatic systems, but not quite as protected as the primary category. Here's White Clay Creek Wild and Scenic River located in PA and Delaware. You have existing conditions, so the degree of disturbance relative to the ability of the site to perform its physical, chemical, and biological functions. So how are you going to disturb it and to what degree? Is it going to be fully functional, partially impaired, impaired, or very impaired? The duration, which is the length of time that the impacts are expected to last. Dominant impact, which is what impact do you plan on having the site? Are you going to clear it, drain it, dredge it, fill it, impound, or shade it? What are you going to do to the site? And then cumulative impact, which is you need to try and get the amount of development or impacts that are going to be occurring in the area and on that site during your restoration. Here's just a little model showing how a mitigation bank works. A developer has 2 options. They can buy credits from mitigation banks in the area, but again, not everywhere has mitigation banks or the same type of projects or credits. So you can locate an area that needs restoration. It has to be in the same watershed and the same ecoregion. Here's an example of the logo for the PA Mitigation Bank, which is currently working on the Chalfont mitigation. 6 determining factors for the amount of mitigation credits you need. First is net improvement, which is an evaluation of the net level or function or enhancement of the restoration to an aquatic site. Upland buffers, which help to maintain the physical, chemical, and biological integrity of the adjacent aquatic resources, which are really important. Your credit schedule, so you need to recognize the timing and how successful the implementation of the proposed mitigation plan is going to be in reality. You have temporal loss, which is that time lag between the loss of the aquatic source's functions and when the replacement of those functions are going to start again through your restoration. You have the kind, so a factor that's used to compare the functions of an impacted aquatic resource with the functions of the potential mitigation site. So again, what type of ecosystem you're doing, it needs to be the same kind as you are impacting. And the location, which is used to compare the location of the impacted resource and the potential mitigation site. And so this is what I talked about. It needs to be in the same ecoregion, needs to be the same kind, and it needs to be in the same drainage basin as whatever you're impacting. Now, example, Hunnick Creek in South Carolina is a restoration project that was undertaken. I personally don't think it was a success. I think they should have started at the headwaters or upstream. One of the big things is they didn't have any type of erosion control structures at the four outlets for the wetland to drain, which is one of the big issues because it keeps eroding back further. And that's something they identified in their mitigation plan. They didn't add any duck boxes, which was another thing in their restoration plan. I think that they could have created more natural meanders than what they did. Um, is just in my opinion though. It is not the wetland has not been restored to a bottomland hardwood wetland, which is what they destroyed to put in the public. So that needs to be fixed. And potentially in a few years, it could grow into that. We don't know. And the other thing is the potato vine. While this isn't an invasive, when they went in for invasives, they should have checked and seen that this vine was growing and tried to remove it because it has killed off a lot of the vegetation that they planted, which could be why it's lacking the bottomland hardwood wetland that they wanted to convert into. I don't know. But here's an image taken during the restoration of the Hunnick Creek, and you can see they're adding some meanders in through different water structures. So that is my midterm. Thank you for watching.